Good day, everyone. My name is FANG from Xuzhou University of Technology. I'm really honored to have this opportunity standing here to have my presentation for my paper. And you are welcome to communicate with me by email shown on the screen. My paper is named Simulation Research on Modular DC Grid-Connected PV System, and it consists of 5 parts. First of all is introduction. In this part, I will explain the reason for what I do this research and what can we do for industrial area. In the second part, I will show you the circuit structure of isolated 3-port DC-DC converter and the advantages of this topology are explained theoretically. In the third part, the control strategy of modular DC grid-connected PV system based on 3-port IBLLC resonant converters is analyzed. And in the fourth part, the simulation model of the 3-port IBLLC resonant converter is built by using MATLAB Simulink software. Verify the working principle and the characteristics of the converter. Then, based on the simulation model of the converter, the simulation model of the modular photovoltaic DC grid-connected system is built to verify the characteristics of the system and the effectiveness of the voltage sharing control method. At last, the conclusion is given with my modulation model and the results. So let's start. Introduction. In recent years, with the development of all kinds of independent power generation systems with energy storage devices, 3-port DC-DC converters have been more developed and applied. According to the isolation between the 3 ports, these converters can be divided into non-isolation, semi-isolation, and full isolation types. An efficient 3-port interleaved boost LLC resonant converter is used as the basic converter unit of the modular DC grid-connected photovoltaic system in this paper. The bidirectional port of the converters is connected through a low-voltage DC bus to solve the problem of unbalanced output power and voltage oscillation of each module in this system. The structure of the semi-isolation and fully isolation type 3-port DC-DC converter is shown in Figure 1. The 3-port IBLLC resonant converter is used as the basic converter unit in the modular photovoltaic DC grid-connected system studied in this paper. The structure is shown in Figure 2. The input port of a single converter is connected with the photovoltaic module to form a basic power unit. The two-way ports of all converters are connected to the low-voltage DC bus in parallel, and the output ports are cascaded to the high-voltage DC bus. For the photovoltaic MPPT control of the 3-port IBLLC resonant converter input port, the actual output voltage UPVI and current IPVI of the photovoltaic module are sampled, and the maximum power point voltage UPVI asterisk obtained by the MPPT algorithm is used as the voltage reference value of the converter input port. Then the duty cycle DI asterisk is calculated by the PI controller and feed-forward link. In the constant power operation mode, the central controller is required to monitor the operation status of the modular photovoltaic DC grid-connected system and send control commands to the local controller of each power unit to ensure the regular operation of the modular photovoltaic DC grid-connected system. The simulation model of the three-port IBLLC resonant converter is built by using MATLAB Simulink software to verify the working principles and characteristics of the converter. Then, based on the simulation model of the converter, the simulation model of the modular photovoltaic DC grid connected system is built to verify the characteristics of the system and the effectiveness of the voltage sharing control method. The working principles and features of the three-port IBLLC resonant converter and the modular photovoltaic DC grid connected system based on the converter are simulated and verified. Figure 6 shows the primary voltage and current waveforms of steady-state simulation of three-port IBLLC resonant converter with switching frequency at 50 kHz, and the duty cycle is 0.4, half, and 0.6 respectively. When the duty cycle changes, the operating characteristics of the converter would change accordingly. Figure 7 shows the simulation results of the modular photovoltaic DC grid connected system when the photovoltaic input power of some power units changes due to the change of light intensity. Figure 8 shows the simulation results of a modular photovoltaic DC grid connected system based on the three-port IBLLC resonant converter when the photovoltaic power supply of some power units is disconnected. So the simulation results, the rationality of and effectiveness of the modular DC grid connected photovoltaic system and its voltage sharing control strategy are also demonstrated. Thank you very much for watching my presentation, and don't be hesitant to contact with me by email. I'm glad to communicate with you. Thank you very much. Goodbye.